All right, today we're going to begin our discussion of the unit circle. So the unit circle is a circle whose radius is 1 and centered at the origin 0, 0. So on the x and y axis, this is our point 0, 0. This is the center of our circle. The radius length is 1. So that means this coordinate here is 1, 0. This point here is 0, 1. This point is -1, 0, and this point is 0, -1. All right. Before we really get started, we need to discuss angles. So once again, yeah, this is called the unit circle. It's centered at the origin, and it has a radius of 1. Before we do anything else, we're going to discuss angles. Now, an angle is really just two rays. Rays are an endpoint and a direction that goes on forever. And when you connect two of them to the same point, known as the vertex, you get an angle. One of the rays is called the initial ray, which is the starting ray, and then it rotates to meet up with the terminal ray. Now you can rotate clockwise, which is a positive rotation of an angle, so this could be maybe 60 degrees. And if I were to have rotated around the other way instead, terminating in the same place, these two angles would be called coterminal. So coterminal angles terminate in the same place. So both of these angles start on this initial ray, and they both end on this terminal ray, but one of them rotates positive 60 degrees this way. The other one rotates around the other way, which is actually a rotation of negative 300 degrees. So the total rotation in a circle is 360 degrees. Just to clarify that, I'm sure we can agree that this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. Together is 360 degrees. So, but the angle measurement of 30 and negative 300, of 60 and negative 300 are called coterminal because both of those angles will terminate at the same point. All right. So, an angle drawn in what's called standard position will have its first ray drawn on the positive x-axis. The other ray will terminate wherever it needs to terminate, and there will be several angles that can be referred to as that angle. So I'm just going to split up the axes here into eighths to help us estimate what certain angles measure. If our angle were to end here, it would be 90 degrees. A coterminal angle would also be, so this would be 90 degrees. If we went the other way, it would be negative 270 degrees. We can also go around the circle more than once, so instead of going around straight to 90, we can go around an additional 360 degrees, which would be 450 degrees, and end in the same place. So these angles are all considered coterminal. You have negative 270, which is equal to 90, which was equal to 450. So once you have your first angle, you can either subtract 360 to find a coterminal angle, or add 360 to find another coterminal angle. So if I add another 360, I'll get another coterminal angle, and vice versa. So those are coterminal angles. The other thing we'll want to address now is estimating our measurements around a circle. If a circle is broken up into any particular number of equal sections, you can estimate very easily. Like for instance, we know that this angle is 90, this angle is also 90, this angle is also 90, and this angle is also 90, and that's because we know that 360 degrees is split up evenly into 4 equal parts. If I were to break up the circle into eighths, we can estimate each of these angles as well. So now each of these sections should be 45 degrees. So if I were to ask you what is the measurement of this section here, it should be 135 degrees. Now this angle is not in standard position because it is not starting on the positive x-axis. The measure of this angle would be -45, and so on. We can do the same thing with other breakdowns. Instead of cutting it into fourths, let's cut both the top part of our unit circle into thirds and then the bottom as well. Trying to do this evenly. Whoops. So each half will have 3 sections, and that makes this angle here 60 degrees, because 60 plus 60 plus 60 will add up to 180 degrees. If I add another 3 of those 60s, we get 360 degrees. So if I asked you what the measurement of this angle was, we should know that it's 300 degrees going this way, or coterminally it would be -60 degrees. Now there's a different type of measurement around a circle besides degrees. We've talked about it in class several times. It's called radians. So what a radian is just the definition of a portion of a circle defined by the radius. So degrees is just an arbitrary number that says there are 360 splits of a circle. So the last thing I want to talk about are called radians. So a radian is just a different measurement. 360 degrees is the full distance around from the initial ray terminating back in the same place where it started, or the full distance around a circle is 360 degrees. In radians, that is equal to 2 pi radians. And a radian is really just a definition of the distance around a circle defined by the radius of the circle. So if r was the radius, then the distance equal to r along the circle would form a particular number of degrees, and it takes 2 pi of these to go around the entire circle, which is about 6.28, or 2 pi. And that has to do with the circumference formula of a circle being equal to 2 pi r. So that's where it comes from. So 360 degrees is equal to 2 pi radians. So if I asked you what the distance around this, what the measure of an angle around this entire circle was, in degrees, the answer is 360 degrees. In radians, it is 2 pi radians. So what is 180 degrees in radians? So that's the distance around half the circle. That should be equal to half the distance around the whole circle, so it should be pi radians. The distance of a quarter circle is 90 degrees, which would be equal to half of the half circle, which is pi over 2. So radians are often going to be written as improper fractions. We can get some other key measurements as well. So if we wanted to get 45 degrees, that would be equal to pi over 4. If I wanted to get 30 degrees, I would take 90 degrees and divide it by 3, and that would be pi over 6 radians. 60 degrees would be double that, or pi over 3 radians. So these are some of the more common ones you'll see. There is a formula for simply converting one to the other. So 1 degree is going to be equal to pi. 1 degree converted into radians is going to be equal to pi over 180 radians. So if you ever want to convert from degrees to radians, you multiply by pi over 180. If you want to convert 1 radian into degrees, you multiply by 180 over pi degrees. So that means if I had 52 degrees and I wanted to turn that into radians, I would multiply by pi over 180 radians, and then I will have an answer in radians. So I get 52 180 over 180 radians. which we can then simplify pi radians, excuse me, 52 pi 1 over 180 radians, and we can simplify that fraction as needed. 4 goes into both of those evenly, so that would be 13 pi radians over 45. So 52 degrees is equal to 13 pi over 48. We can convert in reverse as well. So if I told you I had 4/5, let's say 4/3 pi radians, and I wanted to convert that into degrees, I'm going to multiply by 180 over pi, put degrees here. The pi's cancel out. 3 goes into 180 60 times, and this will be 240 degrees, which should make sense because we said pi over 3 was equal to 60 degrees times 4 would be 240 degrees.